welcome to section 6 of unit 3. Let's look at the section objectives. By the end of the section, you should be able to 1. Represent systems of equations using matrices. 2. Solve problems involving linear equations using matrices. A system of linear equations can be put into a matrix form. For example, write the matrix for the system x plus 2y is equal to 9 and 3x minus y is equal to 13, and use it to solve the simultaneous equations which make up the system. Let's look at how to solve this in the next slide. Let's look at the solution. To solve the system, we have to write the matrix equations. And to write the matrix equation, we have to isolate the coefficients from the variable. So the coefficients will form the matrix, and then it will be multiplied by the variables. So the coefficients are 1, 2, 3, negative 1. Then the variables are 2, x and y. Then it will be equal to the constant. So that we call that one equation 1. Then we let the matrix that we have formed be represented by a letter. So let's use letter A to be equal to 1, 2, 3, negative 1. Then we will find the inverse of the matrix. We have gone through the procedure for finding the inverse of a matrix already. So this one will provide the answer, which is negative 1 out of 7 into bracket negative 1, negative 2, negative 3, 1. Now, we'll multiply each side of the equation by the inverse of A. That is equation 1. So we bring the inverse of A to multiply the left side of the equation 1 and use the inverse of A to multiply the right hand side of equation 1. And we have learned how to do multiplication. So we do the multiplication, and at the left hand side we will have 1, 0, 0, 1 against xy. Then at the right hand side we have negative 1 out of 7 into bracket negative 35, negative 4. And when we simplify that, we see that xy will be equal to 5. We conclude therefore that x is equal to 5 and y is equal to 2. Let's look at another example. Solve the system 2x plus 3y is equal to 1. 4x plus 5y is equal to 1. So we will first write the matrix equation from the system. To write that, we isolate the coefficients from the variables. So the coefficients are 2, 3, 4, 5. And that will be multiplied by the variable xy. And it will be equal to the constants 1. So we call that one equation 1. Now we will take the matrix and let it be represented by an alphabet. So here we use the alphabet B. So B is equal to 2, 3, 4, 5. Then we find the inverse of the matrix B, which is negative 1 out of 2, 5, negative 3, negative 4. We continue with the solution. Now we will use the inverse to multiply both sides of equation 1. So we use it to multiply the left side of equation 1 and the right side of equation 1. Then when we simplify the left hand side, we have 1, 0, 0, 1 against xy. And then when we simplify the right hand side, we have negative 1 out of 2 into bracket 2, negative 2. Then when we use that identity matrix to multiply xy, we get xy. And when we simplify the right hand side, we get negative 1, 1. We therefore conclude that the solution for that system is negative 1, 1. We will now use an alphabet to denote the matrix that has been formed. And so we let the capital letter A be equal to the matrix, which is 1, negative 1, 2, negative 3, 1, 2, 3, negative 2, and negative 1. Then we will find the inverse of this matrix. After getting the inverse, we will use it to multiply both sides of equation 1, as we have done in the 2 by 2 matrix. As has been the case, you will see that when you simplify the left-hand side of the equation, it gives you the identity matrix. So we have the identity matrix for a 3 by 3, multiplying the variables, and it is equal to the right-hand side of the equation. And so when you use the identity matrix to multiply the variables, you get x, y, and z. And that will be equal to 3, 2, 1 when you simplify the right-hand side of the equation. The solution set is therefore 3, 2, 1. This means that x is equal to 3, y is equal to 2, and z is equal to 1. Thank you for your attention.